So this video is on Integrated 2, RFF, Review for Final Exams, number 1 for semester 1. And we have a parallelogram. Area of a parallelogram is equal to base times height, and your base and height have to be perpendicular. So here we have this base, which is 8 because that's 8 up here. And then this is our height because again, this is perpendicular with this. So I'm going to be using this 5 and this 8. So area is equal to 8 times 5 or 40. On number 2, write a quadratic equation from this. So here's our x-intercept, here's another x-intercept. So I know it's going to be y equal a times, because of this -5, it came from the factor x plus 5, because -5 makes this 0. Okay, and whatever makes this 0 is going to be your x-intercept. Same idea here, that's a 2, so that came from an x minus 2. Now you can use any of these points at all besides your 2 x-intercepts to find your a. So I think the easy one to do is your y-intercept because it has a 0 in it. So I'm going to go -10 is equal to a times 0 plus 5 times 0 minus 2. So I get -10 is equal to a times 5 times -2. I get -10 is equal to -10a. So your a is 1. Okay, so our a is 1. So that means I just need to multiply out the x plus 5 and the x minus 2. You can do an area model. If the number in front of your x is a 1 in both of them, you can actually just think about it as a diamond. So I have a 5 and a -2. Those multiply to a -10 and they add to a 3. So that means my answer is going to be y equal x squared. The sum is always your x, so plus 3x. The product is always your constant, and that's going to be our answer. Number 3. Okay, on numbers 3 and 4, okay, we've got these points, so we're going to plot 2, 4 and 9, 10. So 2, 4, which is A, and then 9, 10, which is B, and then we have this line. I'm going to make it a little fainter. We have this line here, and we want to know the slope. So for the slope, I am going to figure out how am I moving from here, whoops, all the way up to here, sorry. So how am I moving from here to here? And so that is going to be 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7. So 6 and 7. So it's always your change of y. This is your change of y over your change of x, this being your change of x. So this is going to be 6 over 7, 6 sevenths. Now, what's the length of AB here? So this is a right triangle. So you can think of using Pythagorean theorem. So I've got a 6, a 7, and I'm really trying to find like the C here. So I'm going to go 6 squared plus 7 squared equals C squared. And when I do that math, okay, I have a 36 plus a 49. I end up with an 85 is equal to C squared. So the square root of 85 is not going to be a nice answer. It's going to be a decimal. So 9.2. So it's about equal to 9.2, but let me just write, this is what it is exactly. Exactly, it is the square root of 85. And again, that is about a 9.2. 9.22 if I give 2 numbers after the decimal. Accuracy. Now I could try to simplify square root of 85, but when I take 85, I know it's divisible by 5 for sure. I get a 17, so a 5 and a 17, both of those are prime numbers. I cannot break down my 85 any further. So square root of 85, or if it's as a decimal, 9.22. Number 5. So on number 5, these triangles are similar. And so I'm just going to list this. That means ABC is similar to DEF. So the reason I'm doing this is A and D are the same, B and E, when I say the same, they're the same size angle, okay, because these are similar, but they're corresponding. B and E are corresponding, C and F are corresponding, okay? So that's helpful when you're trying to match things up. So I'm just going to kind of color code those are similar, or I mean, I shouldn't say similar, or corresponding. These are corresponding, my B and my E, and then obviously the ones I didn't circle, my C and my F. So you want to kind of pay attention, make sure you're matching things up. So what I know is I know this pair. So I'm going to use that. I'm going to say 6 over 5 is equal to, and now I'm trying to find X. If I'm doing 6 over 5, you see these are in the same spot, 11 over X. I'm going to cross multiply and solve, so I'm going to get 6x is equal to 55. So x is equal to 55 over 6. Now for the y, again, I'm going to do 6 over 5. So 6 over 5, and then y over 7. Y over 7, I'm going to cross multiply. 5y is equal to 42. So y is equal to 42 over 5. And that's going to be our answer. On number 6, we have a trapezoid. These are parallel. We also know that this side and this side are the same, so this is an isosceles trapezoid. So what that means is in an isosceles trapezoid, if we have these sides that are the same, then the angles opposite them are going to be the same. So these base angles, that 40 and this angle X are going to be the same. So I know that X is going to be 40 degrees. Why? Because this is an isosceles trapezoid. Now I also need to find my Y. So I'm going to think of this as a parallel line. Parallel line, these are parallel lines cut by this transversal. And so when I see that, what's going to happen is this angle here, 40, and this angle here, these are not the same angle, okay, but these are same side interior angles, and those add up to 180. So I know that if I take 80 minus 40, I will get my y. So my y is going to be 140 degrees. Number 7. On this one, I'm going to first look at this big triangle here. And I know that in this big triangle, this angle that I'm drawing in purple is going to be basically 180 minus 43 minus 39, okay? Because of the triangle angle sum theorem. So I'm going to go 180 minus 43 minus 39, and I end up with 98. Okay, so this whole thing here that I'm shading in purple, this whole thing is 98. Now, you'll notice we have this marking and this marking, which means these are the same. So this X is going to be half of 98. So I'm going to take 98 divided by 2, and I end up with 49 degrees, and that's what our X is going to be. On number 8, okay, we're going to use the quadratic formula to solve that. And you always have to have it equal to 0 before you start finding your A, B, and C. My A is going to be 4. My B is going to be a -3. And my C is going to be a -2. And then my formula is X is equal to -B plus or minus the square root of B squared minus 4AC all over 2A. Now, where a lot of us have trouble is with this 2 spots. This is a -B, which means make your B opposite, Okay, so that, since this is a -3, this is now going to be a +3. So I'm going to get 3 plus or minus the square root. And here you want to make sure this is a -3 being squared. Do not write it like this, because if you type this into your calculator, it's going to give you a -9, but I'm squaring -3. I should be getting a +9. So again, if I type it in like this, it's saying square, then make it opposite. So it's always going to give me back a negative. I want my -3 to be squared, which is a +9. So you want to be careful how you write this. So this is a -3 squared minus 4 times my a, which is 4, and my c, which is a -2, all over 2 times my a, which is 4. Okay. So now I am going to put that into my calculator. So I'm going to get 3 plus or minus. And when I say put in my calculator, I'm going to be putting this, what that's underneath my radical. Okay, let me highlight it. I'm going to be putting this right here. I'm highlighting that into my calculator. Okay, so I'm going to get a -3 squared, or you can just type in 9. Minus 4 times 4 times -2, and I end up with a 41. Okay, now 41 is a prime number, so I cannot simplify the square root of 41 at all, over 6, and this is going to be my answer. This is my answers, I should say, because I get a plus and a minus. On 9. On 9, we are trying to solve for x, okay? We have two sides of a triangle and a right triangle, so we're going to use Pythagorean theorem. And always pay attention to where your hypotenuse is. This is your hypotenuse. So it's always a squared plus b squared equals c squared, where your c squared is, or your c is your hypotenuse, okay? So I'm just going to put a little note here, c equals, I'm going to abbreviate it, hypotenuse. Okay, c is hypotenuse. So I'm going to be going 6 squared plus 1 squared equals c squared. So 36 plus 1 is 37 is equal to c squared. So the square root of 37, again, 37 is prime. So this is as simplified as that can get, unless you put in your calculator and get a decimal, but this is the exact answer. On number 10, we are solving by factoring, okay, using the zero product property. So for this, I'm going to do a box and a diamond. I am going to be putting the 2x squared here and -3 here. These multiply and give me a -6x squared. This diagonal multiplies to -6x squared. We saw that this also has to multiply to -6x squared. That was always the pattern. But not only does this multiply to -6x squared, has to add to x. So that's why my sum is x. And then I need to figure out what that is. So that's going to be a 3x and a -2x. So a 3x and a -2x. And then I need to find the outside. And so my 2, whoops, sorry. And let me make this look like an actual minus. Okay. So my 2x goes here and x goes here. X times 3 and 2x times -1. So I am going to get 2x plus 3 times x minus 1 equals 0. And when we have two things multiplying to get us 0, by the zero product property, either this has to be 0, so I set that to 0, which means I would be getting a -3 over 2. I would be subtracting 3, dividing by 2. And this one is going to be x equal 1. And those are my solutions. On number 11, the area of a square is 24 centimeters squared. Find the length of the side. So if I draw a square, I know that a square would be the same sides, both of them. So let's say x and x, and the area is 24. So really I have x squared is equal to 24. I take the square root, and normally when I take the square root, I do get a positive and negative, and just like I did actually in the triangle problem, I'm not going to have a negative side, so I'm just going to focus on the positive. So it's going to be a positive 24. Now, 24, you can simplify. Okay, we want to start simplifying our radicals. Is there any square that is a factor of 24? So 1 squared, and 1 squared is not something that we are going to be considering. Hold on, I'm trying to change this color. So 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Okay, I'm already beyond my number. So do any of these numbers multiply with something to get a 24? Yeah, 4 times 6. So this is really a square root of 4 times a square root of 6. And my square root of 4 is 2 root 6. And that would be my simplified answer. Okay, radical 24 is the same as 2 root 6. Number 12. So on 12, we want to find the value of x. We have a parallelogram here. And what's happening is we have this and this that are parallel lines cut by this transversal. And so we have same, oops, again, trying to change the color. We have same side interior angles that are supplementary. These have to add to 180. So I'm going to take 180 minus 76, and that's going to be my x. Okay. So 180 minus 76 is 104. So this is going to be 104 degrees is my x. On number 13, we have an isosceles triangle. How do I know that? Because of this and this. So that means if this is 42, this is 42. And then in this triangle, I know if I take 180 minus, well, 42 twice. So I'm just going to write 2 times 24 because I have 2 times 42. Apologize. 2 times 42 because I have 2 42s. That will give me my x. So I'm going to go 180 minus 42, just making sure, 42 times 2 because I have 2 of them. And I end up with 96. 96 is equal to x, 96 degrees. On 14, which of the equations below represents a line parallel? Parallel, you have to have the same slope. So let me just kind of highlight or cancel. This is not because it has a negative. This is not because it is actually a negative reciprocal. So this would have been perpendicular. Okay. This one would have been nothing compared to it. They would cross, but it's not going to be it. So my answer is going to be this one because they have the same slope. Number 15 and 16 because they're both here. So 15 and 16, if AB is 5 and BC is 7 and AC is 10, is triangle ABC. Triangle ABC is, and so we have these choices here to pick from. So since 5, 7, and 10 are totally different numbers, it would be D scaling. The next question says if AB is 5 and BC is 5 and AC is 8, what would that be? That would be isosceles, so that would be B isosceles. Equilateral would be where all of them are the same. And a right triangle, you should have it working out doing Pythagorean theorem, and you're having 90 degrees. But if I was to test these would not work, okay? Using a squared plus b squared equals c squared. 17, which of the following triangles below has an area greater? So when you're doing this, a formula for a triangle, area is equal to 1/2 base times height, or base times height divided by 2, whichever way you want to think about it, okay? But your base and height have to be perpendicular, always, 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 always. So here, these are perpendicular. So for this one, my area is going to equal 6 times 3 divided by 2, 18 divided by 2, 9. Now this one here, think about it this way. If I was to turn it like this, okay, and I was to kind of extend this out, my base is 4, but if I had the line extending out, okay, you see that this is going to be perpendicular with this. So this 5 is going to be my height, and this 4 is going to be my base. So I'm going to be doing 4 times 5 divided by 2, okay? So let me get rid of those. Okay, so for this one, my area is going to equal my base, which is 4, the height, which is perpendicular to it, 5, divided by 2. So I end up with 10. So this one has the bigger area, this one right here. Okay, so number 18.